All right, the problem was with amide in water to form ammonia and hydroxide. What was the initial concentration on the amide? .124 or something like that? 0.0125. All right, the initial concentration was 0.0125 molar. This was 0 molar and 0 molar. All right, the first thing I would have looked for, because I always look for potential for resetting, and like I said, we want zeros, but this already has zeros. So the only choice is I could reset it to the right or just leave it alone. And then when I look at my K value, the K value tells me, you know, all the atoms are on the right or all the atoms are on the left. In other words, what's dominant, product or reactant?
Product.
Yeah, it's all product. You see it's all product? In fact, if this were water, this would be like having all the water on the left side and then releasing it, and then there's going to be a huge rush of water to the right side. And so in other words, the change is going to be huge here because this is just totally opposite of where the seesaw is balanced. You know, right now it's all on the one side, and so basically what's going to happen, it's all on this side. Basically, it all has to transfer to this side. You know, so there's got to be a huge change. And that being the case, we want to reset this. And so, you know, automatically I would have said, okay, let's go ahead and reset this. This is going to be minus y, this is going to be plus y, this is going to be plus y. When we reset, we look for limiting reagent. There's no limiting reagent here, and so this is going to just be a stoichiometric. So this is going to be reset initial. Here. All right. Now this is more like it because it should be all product, and it's pretty much all product now, but it can't be 100% product, right? Because K would have to be infinity. And so what's going to happen is this has got to go backwards to create some reactant. And so what we're going to do is we're going to just lose a little bit of this product. And we shouldn't lose much, right? Because it's 10 to the 20th. The ratio is 10 to the 20th to 1. And so we should lose very little of the product to form a little bit of reactant. And so we're going to end up with X molar 0.0125 minus X molar 0.0125 minus X molar. And so this is just equal to the ammonia concentration times the hydroxide ion concentration divided by the amide concentration. And so I'm going to get 0.0125 minus X times the same thing, so I'll just square it, divided by X. If I look at this, hey, this just looks like the quadratic equation. And so let's go ahead and get it into quadratic form. So getting this into quadratic form, I'm going to get X squared. Okay, minus 0.0125x plus a minus 0.0125x gives me a 0.0250x. And then this times this, 0.0125 times 0.0125 is equal to what? Or 0.0125 squared. So let's go ahead and 0.0125 squared. 1.56. And so I'm going to write this in decimal form here. And this is going to be a plus. Is that a plus? Yeah. Plus 0.0001565. I'm carrying extra digits here. Divided by X. Right? All right. And so then I'm going to get 10 to the 20th X is equal to X squared dot dot dot. And that means 0 is equal to X squared. Okay, I'm going to subtract 10 to the 20th from X from both sides. And so 10 to the 20th minus 0.025 is just pretty much going to give me 10 to the 20th. So I'll get, I'll just say 1 times 10 to the 20th. 1 times 10 to the 20th, although that's overestimating the sig figs. This is 0 sig figs, I suppose. X um, plus 0.0001565. Okay, and then you solve the quadratic. Do you guys have an equation solver? Did you guys get the fancy calculator, the $16 calculator? Yeah. And so if you have that calculator, you go to equation, then plug in A, B, and C. If you don't, then we use the quadratic. Are you guys good at solving quadratics? You have to solve a lot of quadratics in this class. If you're doing it on homework, you know, I figure most people have no problem solving quadratics. Unfortunately, my calculator has disappeared. My fancy one. But I haven't replaced it yet. I just replaced it with a $1.99 calculator. Here, my $1.99 calculator does not solve quadratic. So if I were doing this on homework, I just open a web page like this on my phone or on the computer. And the web page would look like this. Let's see. You could just pick any one of the probably 100 quadratic equation solvers online. So let's just pick one of these here. For example, this, the Math is Fun website. And so we know that A is 1. We'll plug that in. So A is 1. B is 1. And then to type in scientific notation, we do 1E20. And then C is 0.0005625. 0.0005625. And I'll just enter that. And this is what we end up with. We end up with x is equal to a negative 100. That would be 100. And negative 1 times 10 squared would be 100, or 0. Huh. Is that right? Negative 100 or 0? That's not right. That's not right. So let me look. Did I make a error multiplying? I haven't multiplied binomials in a while, so maybe I made an error multiplying out the binomial. And so let me double check this one. This binomial, 0.0125 minus x. Um, 0.0125 minus x times 0.0125 minus x. So minus x times minus x gives me x squared, minus 0.0125x minus a minus 0.0125x gives me minus 0.0250x, and then 0.0125 times 0.0125.
I don't think it's saying that 0 is the solution to that.
What is it saying?
Because if you plug in 0 for x, you have 0.005625 equals 0. And it's just rounding something, or it's telling you something wrong.
Well, that's what I'm checking. It must be telling me something's wrong.
I mean,
So
it's not even, that's not even the real solution to the equation you just plugged in. I mean, it might be a right equation.
okay. Well, first I want to check the equation, and then see. Well, actually, it is the right. I have x squared plus 1 times 10 to the 28x plus 0.0005625. What is it? 15625. Let me try. Did I? Let me just try it again. Oops, you're right. I screwed that up maybe. Let's see. 0.0125 squared. 0.0125 squared. Yeah, 0.000. 0.0001565. And so I misentered that here. Let's go ahead and fix that. .0001565. Good. All right, now look here, and this is what I got. I have x squared plus 1 times 10 to the 20th x plus .0001565 is equal to 0. That's the correct formula, right? And so, you know, maybe I shouldn't trust math is fun. Maybe math is fun is for elementary school kids, not for college. And so maybe I should try different. Uh-huh.
You can just use the quadratic formula.
All right. Why don't you do that? Are you good at the quadratic? You know, this is not working, actually. Well, let me just try one more thing, because let me see. Okay, I'm going to just use the Google one here, maybe. Right? Or the Bing one here. This one solves any kind of thing, any kind of quadratic. So what was the formula? It was x squared minus point 0.0250 x plus 0.0001565. Is that it?
You're missing a 0. 0.025.
15625. It's just, you know what I forgot? Excel doesn't care, or whatever. This doesn't care if I put the leading 0 there. X. No, I didn't put the plus in. I can't put the plus in here. Why is it not letting me put the plus in here? Maybe the internet hangs up for a while. Well, basically I'll just tell you what's going to happen. You know what's going to happen? It's going to fail again. So if it fails again, then maybe we don't know what kind of algorithm they use to solve for the quadratic, so we might as well just use the quadratic formula. So are you guys good at the quadratic formula? Actually, did somebody get the calculator? Does somebody have the Casio? What did you get, Javaria? Or you plug in A, B, and C. Okay, if you don't have the fancy calculator, you're going to have to solve these by hand on the test. So can you go ahead and solve it just so you've solved it once before the exam? Or hopefully if you do the homework, you'll solve it a whole bunch of times before the exam just to make sure you got it down. Good.
One of my x values is 0.03.
0.03?
0.0301.
0.03. Okay, 0.031. And what's the other x value?
Negative 0.005.
Negative 0.005. Well, unfortunately, both of these are impossible. If we have 0.031, then 0.0125 minus 0.03 gives me a negative number. I can't have a negative molarity. And then this is already negative, and that would make this negative. And so both of those, and so maybe 15.
For the B, is it 0.0250 or?
Did I miss a 0?
Yeah, you missed a 0.
Okay, sorry. Yeah, 0.0.
No, it's over here. No, you got the 0 over here, but like when you type it on the computer.
Oh, well, take a look at how I see. I messed it up here. Anyway, I can't edit this because the computer's web page just hung up. unusual. I don't know why. Our computers are having such a hard time. So unfortunately, there's Chrome on here. Let's see if this will do it. Well, Math is Fun is the one we try. Let's go to math.com. That sounds more. Oh, how about Wolfram? Wolfram has a free quadratic equation solver. Yes. Now, Wolfram is pretty. Have you guys heard of Wolfram? They make extremely powerful piece of software, but A is one. A is 1, B is 1, E to 0, C is 0.000, 15625, 15625. Submit.
Why is, should you put a negative on E20?
Oops, you're right. I do the negative. Submit. See if Wolfram pulls through for us. Well, it's taking a long time for this is a quadratic. Did you solve it by hand? Maybe you can solve it by hand before then.
Why is B equal to 20?
Y is B equal to?
E to the 20?
Do you know what E stands for?
Yeah, the exponential.
No. E stands for times 10 in basic language. For like Excel,
Okay.
if you want to do, it would be equivalent to the double E or the times 10 to the power of something.
Okay.
In Excel language, which is basic. And so it's not the natural, E, whatever, 2 point, whatever it is, which I forgot. How much longer should we give Wolfram to finish this calculation? I probably can do it by hand quicker than that, so why don't you do it by hand and tell me what your answer is? Okay, you know what? Still computing.
I think it's
I think it's stuck. Should I just try to refresh the page? Okay, I'm going to refresh the page. I have to enter it again.
I think it thinks E is the exponential of the multiplier.
All right. How do you want me to enter it?
Negative 0.0250.
No, for B.
Yeah, that is B, right?
No. B is not. Did I screw it up?
The equation on the left side is.
I know, but this is not done yet. Okay, I just double checked multiplying out the binomial. Once you multiply out the binomial, that goes on the right-hand side here, and then I get it in a quadratic form, which is this step here.
Oh,
So I have to get it in quadratic form by subtracting a 1 times 10 to the minus 20x from both sides.
well, so that all equals K on the left side?
Yeah. And so that's why I did one more step. So it's not, this is not the end here, this is the end here. I just wanted to double check to make sure I didn't screw up multiplying out the binomial, and I didn't. It's correct. And so now I have it in quadratic form. I'm just going to use the Wolfram alpha quadratic equation solver to do it for me. And then submit it. Maybe just got hung up. In the meantime, did you guys compute it by hand? Do you compute it by hand? Paul, you did? What did you get?
1 times 10 to the 20.
1 times 10 to the 20 as your x?
Solving that.
Well, unfortunately, that one's impossible too. If you have 1 times 10 to the 20th, then 0.0125 minus 1 times 10 to the 20th is going to come out as a hugely negative number. And then this is going to be 1 times 10 to the 20th molar, which is, you know, even pure water is only 55.5 molar. That would be about as dense, you know, 1 times 10 to the 20th would be more like the density of the nucleus, which is insanely dense. In order to get that kind of molarity, you know. But anyway, did it finish? No. The point is, it's going to fail. I mean, even the Wolfram alpha quadratic equation solver failed. The calculator I recommended, the whatever. How much did you guys pay for this calculator? The calculator, the Casio. You had it before? Hannah, did you buy yours? How much was it? 16. Even the $16, maybe it was a waste. You should have bought the $9, you know, one. But it wasn't a waste because most of the time the quadratic you can solve, right? Just not this case.
When you subtract K from both sides, are you subtracting the K from the X value or K from the constant?
No, because this is divided by x. There. So in this case, this is the ammonia concentration times the hydroxide concentration in the equilibrium. So that's how I got the numerator, 0.0125 minus x squared, divided by the amide concentration, which is x. So the first thing I did was I multiplied out the binomials, and then I double checked if I multiplied it out correctly. And then the next thing is I multiplied both sides by x, which gave me k times x.
Yeah, I see that.
And so then I have to subtract this from both sides to get it into quadratic form, which I did. So I got it in the quadratic form, and then I'll tell you, the $16 calculator is going to fail, and also all the online quadratic solvers are going to fail for this.
Yeah, mine rounds it to 0.
Right. You see, they're all going to fail. So what should we do in this case? Should we say that this is an impossible problem to solve? Is this an no, it's not an impossible problem. Maybe I shouldn't have reset it. If I didn't reset it, you know, yesterday you guys maybe didn't reset it. Were you able to solve it? No. And so I told you, well, resetting is one trick we can use. And maybe resetting made the math even harder because if you didn't reset it, you didn't have to multiply out the binomial, right? But the situation is this. There's one more trick we can use. And what is that one more trick? Well, actually two more. We could use successive approximations, but you're going to be guessing for an awfully long time to get it close, probably. And so there's one more trick we can use, and what is that trick? SA. What does that SA stand for?
Simplifying assumption?
Simplifying assumption. Now, can we use the simplifying assumption on the original initial? The answer is no. We cannot use the simplifying assumption on the original initial. Does anyone know why? We cannot use the simplifying assumption on the original initial because it's bound to fail. And why is that? This is the original initial conditions. Why will the simplifying assumption fail if we left this in the original initial condition? Because what does the simplifying assumption say or state? It states that
Ignore the change initially and factor in later.
yeah, but basically it says that the change is negligible. So if I left this in the original initial conditions, would the change to get to the equilibrium ratio from my initial ratio be negligible?
No.
No, the change would be enormous, right? Because it's all, it's all like this, and then it's got to tilt all the way to the opposite end of the spectrum. Now, here in the reset initial, is the change negligible? Because when I look at the equilibrium ratio says it's all products, so this change should be negligible. And so the reason you have to look at resetting, you look at it with one strategy in mind. When we reset, we always reset to the side that's favored. The reason we reset it to the side that's favored is to make the simplifying assumption more valid. It's not always going to be the case it's going to be valid, but it'll be more valid if we reset it, unless it's already set that way initially.
Since K is so large, would it be a good assumption that Y value is really close to the molarity of
Yeah, that's a very good assumption, but I want the number. I don't want qualitative. We can always say qualitatively it's going to be close to complete
I
reaction.
mean, you could guess an X really close to that number. Probably be correct, but
Okay, what is close? Actually, Kelly, how many nines did you go? How many nines did you go? Well, just tell me. 9 nines. So Kelly guessed this. 1, 2, 4, 9, 9, 9, 9, 9, 9, 9, 9, 9. That's 9 nines, right? That's really close. And what was the K value that you calculated? 10 to the 7th? It wasn't even close. Okay, what are you going to guess next, Ian? What's even closer to 125? Have you ever tried to punch this many digits into your calculator and hit equals? Have you tried to punch? And in fact, can you punch this many? Let me ask you, how many digits can you punch into your calculator before it won't take anymore? Will it take an infinite number of digits if you just keep keying, like when you accidentally rest some papers on the keyboard and you're in Word, and then it just keeps typing numbers. Excel does that too. One time I accidentally left something on there and it just kept typing the number.
a lot of graph calculators take a lot of digits.
Well, are we allowed a graphing calculator?
Well, mine takes like 25, but it rounds to that.
Well, graphing calculators aren't allowed
It's not
officially.
enough.
It's not a graphing. Yours takes 25 digits?
It takes a lot of digits.
Oh, that's pretty good. And then if you were to hit equals, it would retain those digits?
No, it rounds.
Oh, then it doesn't take a lot of digits, because if it rounds, it's not taking those digits. What does it round it to? How many digits?
1.245. Or 1.24 is, yeah. It rounds to the molarity value. Because
To 0.125.
Yeah.
So like for this one, it rounded off at 0.125.
Yeah, which means 100% reaction, but we don't want qualitative. That's qualitative. Qualitative would be, well, it reacts completely. That's like Chem 1A. We would have made that assumption for this particular thing. Remember, strong electrolytes, like strong bases, hydrolyze water 100%. That's Chem 1A. We would have said, oh, it's 100% reaction because it's a strong electrolyte, strong base. But this is Chem 1B. Chem 1B, we want to do it quantitatively. And so tell me how I'm going to do it quantitatively. Uh-huh.
Maybe instead of x equals 1 times 10 to the 30, 1 times 10 to the negative 30. So that's what you said. Because it'd be a very small value.
Well, okay. Well, let me make a long story short because I don't want to talk too much about this. Number two, you might be an old school quadratic equation solver on pencil and paper, but it's going to fail. It's not going to work. You'll try it, and it'll fail. And so how do we do it? Well, we're running out of options. So we're backed into a corner. We're either going to just forget this problem and just say it goes completely, or we're going to try. What are you going to try? Well, we already tried resetting it, and it didn't really seem to help. But in reality, it did help quite a lot because there's a strategy to resetting. What are you going to try? You're backed into a corner. You're either going to come up with an answer, or it's just going to be 0.125, or actually this is not. This is going to be 0, 0, or whatever it's going to come out to. I don't know. Not 0, 0. It'll be 0.125 here, 0.125, 0. So do you have any more options? Yes, you do. An option called SA. Nobody remembers what SA stands for? Simplifying assumption, which we say that the change is negligible, and then we try it. And so we'll just try it. We're just going to say the change is negligible, but if we do that, you know, this was a quadratic, so you should be able to solve a quadratic without having to make any assumptions, but in this case it didn't work, so we'll just go ahead and make an assumption, but just going to add error to this. But you know, the error is going to maybe be significant. You know, is it going to be 5%, 6% error? I mean, as far as not percent change, the error would be different, sorry. And so what we're going to do is we're going to do the SA. If we do the SA, then the numerator simplifies into 0.0125 minus x. So this would be like a drop of water out of a swimming pool squared over x. And so now we can get it here. And so we do this, we're going to come out to 0.0125 squared divided by 10 to the 20th. And so divided by 1 times 10 to the 20th. We get x equals 1.56 times 10 to the minus 24. All right, now that is an extremely small change. If you look at it, let's go ahead and calculate the percent change. The percent change, or the percent reaction, the reverse reaction here is going to be the change, which is 1.56 times 10 to the minus 24 over the initial 0.0125 times 100%. And this is going to give us, so divide this by 0.0125 times 100. This gives us 1.25 times 10 to the minus 20%. Now, is that, if you lost, let's say you lost 1.25 times 10 to the minus 20% of your bank account, is that pretty negligible? Yeah, that's pretty negligible. And so this is way, way, way less than our 5% cutoff. Our 5% cutoff is huge. So what this tells me is that this is a really good assumption and that the error should not be so significant in this. But what I said, and Javari said this, is we ignore it and then we factor it in, right? And the way we're going to factor it in is how? Well, we'll factor it in over here. It's going to be, the x is going to be 1.25 times 10 to the minus 20, well, no, I read the wrong one, sorry. 1.56 times 10 to the minus 24 molar here. And so how much of this do we lose? And so let's see how much we lost. So this is going to be 0.0125. And so I'll do this over here since I might need a little bit more room to do this. .0125 minus 1.56 times 10 to the minus 24. Your calculator can't. Try to punch this into your calculator. What happens? What happens when you punch it in your calculator? What's the answer? Well, do 0.0125 minus 1.56 times 10 to the minus 24 equals. What comes out as the answer?
1.25 times 10 to the minus 2.
Yeah, if you punch this in your calculator, then it says the change is 0 because it comes out to 0.0125, which is a rounding error, right? To avoid the rounding error, this is what we'll do. We'll go 0.0125, and then we won't worry about the calculator. Because this is 10 to the minus 24, which means I need 23 zeros. So I'm just going to count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 23 zeros, and then a 1, 5, 6. And so I'm going to add some zeros here. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17. And then I'm just going to do this by hand. And so doing it by hand, this is going to be 10 minus 6 is 4, 9 minus 5 is 4, 9 minus 1 is 8, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 4, 2, 4, 2, 1, 0, 0. 0.0124. Now, how long would it have taken you think, Ian, to guess this number?
Well, I couldn't do it with my calculator.
No, I mean for the guess and check. Or Kelly, how long would it have taken? Yeah, you wouldn't have been able to do it, but even if you were able to do it, would it have been an easy number to guess? No. And so this is the molarity. Obviously, this is going to round to this, but what we see is we lose a tiny bit, a tiny fraction of the product. So indeed, the change was negligible here. And so this is the molarity here that we're going to have here. And this would be the same molarity here. And so we just see we're going to lose a tiny, tiny, tiny amount. And that would round to 0.0125, but I'm not asking you what, I want to know what the change is. And the change is exceedingly small, but did I get it right? And so I would just check this to see if I got it right by plugging it back into K. And so we can just plug it back into K and see if that works. And so I'll try it on my $1.99 calculator. 1.56 times 10 to the minus 24. Divided by this squared. And so divided by 0.0124, and then 3, 6, 9, 12, 15, 18, 19, 29 and an 8-4. Let's see if I can get that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Even though I can punch those into my calculator, is it going to compute it with 29s in there? No, if I read the manual is going to say computes it with 8 to 10 digits, depending on it. I think this one's 10 digits it carries in calculations. And then it'll automatically round it. But I'll just go ahead and plug it in here, 844 squared. And what do I get? So if I double check my K, I'm going to get 9.98 times 10 to the minus 21. And so I'll just round that. If I round that, that comes out to 10 times 10 to the minus 21, which is going to come out to 1 times 10 to the, is it minus? I screwed up. I have to invert it. It's this squared divided by that. I did it the opposite. No, let me redo the calculation. It's got to come out the other way. And so let me just redo that quickly. 1, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 8, 4, 4. I think it was 29. But it doesn't make any difference anyway because the calculator's not going to carry it. Squared, okay, divided by 1.56 times 10 to the minus 24. Okay, let me redo this. And it comes out to 1.0016 times 10 to the 20. And so, is that good? That's good. And so the point of doing this is you're going to have to learn this. Otherwise, okay, if you don't learn resetting and you don't learn simplifying assumption, then you're going to lock yourself out being able to solve a bunch of problems. Okay, and so make sure you learn this. Anyway, that concludes chapter 15. Again, so work on the homework. If you have questions on the homework, we'll cover that. What we'll do today is we'll just go ahead and start the lab, I think. That way you'll get an idea. You already have an idea of the reactions in the first series of tests. I'm not sure how far you'll make it. Iron, maybe? We'll see. And then we'll continue this. This is going to be an ongoing lab. I'm not sure if I have it scheduled next week. I have to take a look. We're going to have some breaks. We're going to have some breaks so you can reflect on. You have some time for some reflection on this. And so, like I said, the knowns are going to be, you're going to work with a partner or solo. I wouldn't go into, I would really avoid a group of 3 if possible, because a group of 3, you're going to have to do it by yourself. And sometimes the third person doesn't do much unless everybody, And the thing is, even if you work with a partner, don't do this. You do this half, I'll do this half, and then we'll combine. Because then you aren't going to see half the results from the experiment, and when you do it by yourself, you're going to come up to me, you're going to come up to me and ask me, this. The instructions call for 16 molar nitric acid. We only have 15 molar. And so somebody gets on their unknown and they say, oh, we don't have any 16 molar. And I would have expected them to know this by now because they did the known, but apparently they didn't do the known because their partner did the known for them. And so they didn't know that it's okay to use 15 instead of 16. And so make sure that you, even though you might work with a partner, make sure you actively go through the results together with your partner. Don't let your partner do the work, or don't let your partner just slack off there. But both of you should be analyzing the colors and the results and what to expect, and then it works well. Okay, so you'll get the known solution from the stockroom. Now the known contains some hazardous species like silver. What does silver ion do? Silver ion is a pretty decent. There are two things, two complications. One, silver ion has toxicity. It's a heavy metal, so it loves sulfur. It's a soft metal, so it loves sulfur. containing proteins and that kind of stuff, so precipitates. So it's got metathesis and acid-base type properties. But one of the properties that we have to worry about is it's an oxidizer, and it'll oxidize your skin easily and precipitate out tiny crystals of silver metal. Did I tell you about the person who had the job interview? In this lab, a person had the job interview, and she spilt silver nitrate on her fingers. And it just made some splotches all over, black, brown splotches. And she came up to me and she told me she was, since I already told you, it was this lab, so watch out, okay? Don't spill it. Did I tell you about that? I didn't tell you? She said she was washing her hands for like 30 minutes, 45 minutes non-stop with scrubbing and lots of water. And I looked at her hands and there were splotches of silver nitrate stains all over, which is just, in other words, she had tiny crystals of silver which looked black in her skin, and you can't wash it off. You just got to wait until it sheds off or whatever. And she had a very important job interview, and I felt so bad for her, because. But anyway, so she was very upset. But I gave the same warning in her class. Watch out for the silver nitrate. Watch out for some of the other stuff. Nitric acid. Do you know what color? Fortunately, she didn't have both nitric acid and silver nitrate, because nitric acid, she'd have yellow splotches all over. Silver nitrate, she'd have brown-black splotches all over her hands. But if you do spill nitric acid, you're going to get some yellow splotches on your hand. If you spill sulfuric acid, you're going to get charred skin. One semester, somebody spilled some concentrated sulfuric acid on their hand, and it looked like a little chunk of charcoal right there, and they had a little third-degree burn on their hand. What else? Then the typical stuff: burns, and splashes, that kind of stuff. So just be careful, because chromium, chromate. We're working with a powerful oxidizer. The powerful oxidizer. Do you know which one is the powerful oxidizer we're working with today? We were working with a powerful oxidizer the other day, chromium-6 and dichromate. But today we're working with an even more powerful oxidizer. Do you know what it is? It's hydrogen peroxide, but you wouldn't think hydrogen peroxide, is that all that powerful? Well, it's got to be powerful. If it can convert chromium-3 to chromium-6, it's got to be powerful, because chromium-6 is already a powerful oxidizer. So chromium-6 must be a weaker oxidizer than hydrogen peroxide. How is that so? Because you can go to the supermarket and buy hydrogen peroxide off the shelf. How is it so? It has to deal with concentrations. If you dilute things down enough, in high school, my chemistry teacher always said, I'm going to take some HCl and some sodium hydroxide, mix it together, and drink it. And so every day I waited for that, to happen. It never happened, But it's true. They can drink it. But you know what? You can drink HCl, and in fact, everybody drinks HCl every day because of the water. Like our DI water, not everybody, but if you drink out of the tap, you're going to be drinking HCl, because the pH of our water is like 4 or 5. Out of the tap it's like 5.5, and you have hydronium ions and you have chloride ions. That's HCl. And so I've been thinking, well, you drink it every day anyway. But the reason you don't die is because it's so dilute. And the hydrogen peroxide in the supermarket is very dilute. And so there are factors that'll change the reactivity of these things. Well, the hydrogen peroxide we're using is not so dilute. I think we're using 30% hydrogen peroxide. Is that right? If we're using 30% hydrogen peroxide is pretty nasty stuff. One time, this is before TSA. Before TSA, there's a person who bought a gallon jug of I think it was 30% hydrogen peroxide for their garden. They use it for gardening. And they got it cheap, and so what they did was they saw it in some nursery or someplace here in LA. They put it in their luggage and then got on a flight. It turned out it was just in one of these gallon milk jugs, and so the hydrogen peroxide ate through one of these gallon milk jugs and then started eating through their luggage, and then as it dripped onto the luggage, it caught the fabric on fire, and so there's a fire in the cargo bay, and they had to make an emergency landing after that. And the funny thing is during the inspection, the inspector noticed it, 1 gallon of liquid, and then they were talking to each other, and they were saying, oh, it's just hydrogen peroxide, no big deal, and so they let it go. But it was a big deal because it's not like household hydrogen peroxide. This stuff is nasty. All right? And so be careful with that, and we'll leave it. Nowadays, there's no way you could bring liquids, on the plane like that. But you could read about it. It's a very well-known incident that happened.